Well, good morning. We're going to be looking at today the fifth part of our video on exponents. This is the one that's going to be a little bit challenging. Rational or fractional exponents. Just a little confession, I didn't sleep well last night. My wife and I had a little argument. Well, she keeps nagging me. She keeps saying that I have no sense of direction. You have no sense of direction. Finally, I got sick of it. Just packed my bags and write. So, but it'll get better, don't worry. So keep in mind, as we're talking about fractional exponents, they are still going to obey the properties of exponents. Properties of exponents apply no matter whether the exponents are integers, or zero, positive or negative, or even fractions. So keep this in mind. You got the same base multiplied, you add your exponents. You got a power taken to a power, you multiply your exponents. You got a ratio in which you have the same base, a fraction in which you have the same base. You subtract the smaller from the larger, wherever the larger happens to be. It's not always in the top of the fraction. All right, so let's get to 7.R.3. By the way, there are already notes and problems on Blackboard for 7.R.3, but this is just a little emphasis. Look at an example. Here's my favorite example, 8 to the 2/3. As we evaluate a fractional exponent, you always have the option of re-expressing it as a radical expression. And notice I got three numbers, 1, 2, 3. They each take a place in this radical expression. The base becomes what's called the radicand. That's just simply the number underneath the radical. The denominator becomes the index. That's the little number that goes in the crook of the radical that tells you what kind of root you're looking for. And the numerator becomes the exponent. Now you can either put the exponent on the outside or the inside. Or you can do this way. Either way is fine. So the exponent can go on the outside or the exponent can go on the inside. So basically 8 to the 2/3 tells me I have a job to do. I've got to find what's called the cube root of 8. Then I have to take it to the second power. Now you have a calculator that will allow you to find the cube root of 8, the cube root of 125, the cube root of 27, the cube root of various perfect cubes. I look on my calculator, find that the cube root of 8 is 2. I'm going to square that now. 4. So 8 to the 2/3 turns out to be the cube root of 8, which is 2, squared, turns out to be 4. Now, as long as you have just regular numbers and no x's and y's, etc., you may use your calculator to find 8 to the 2/3 power. If you choose to do that, you'll do it this way. Submit 8. Use your to the power of function key. You guys have that. Some of you guys have a x to the y power or y dx power. 8 to the. Now if I do 2/3 like this, 2 divided 3, my calculator is going to misunderstand. It's gonna think I want to take 8 to the second power, whatever that is, divided by 3. I don't want to do that. I want to take 8 to the 2/3 power. So you're going to have to put it in parentheses. Don't forget to put your equal at the end. If you don't hit equal at the end, it's going to give you a strange looking answer. So 8 to the parentheses, 2 divided by 3, close parentheses, equals, you should get 4. Make sure you can do that on your calculators. All right, so when we have a fractional exponent, we can express it as a radical. Let's look at a couple of examples like that. In fact, let's use one of your Hawk's problems. 27 over 1,000 to 2/3. All right, here's a good principle to remember. If you have, if you have a fraction to a power, you can re-express this as numerator to that power over the denominator to that power. And it's because of this property of exponents right here. This is actually a power, or powers to a power. Multiply the outer exponent by the inner exponents, and I get this right here. So it's basically two problems. It's the cube root of 27 squared over the cube root of 1,000 squared, based on our understanding of a fractional exponent. Now, you can either use your calculator, or you can use the little chart that I gave you in your notes. Did you get that perceived in your notes? The little chart has all these numbers to powers. You might want to have that handy when you take your test, because you can look in your chart and discover that 27 is the same as 3 cubed. So the cube root of 27 is going to be 3. And I want to square it. And while it's not in your chart, the cube root of 1,000, you just simply, I got 3 zeros. Hey, it's 10. Remember this. 10 to the first, 10. 10 squared, 2 zeros, 100. 10 to the third, 3 zeros, 1,000. So the cube root of 1,000 is going to be 10. You can also use your calculator to find that. And that's squared. So 3 squared, 9. 10 squared, 100. So 27 over 1,000 to the 2/3 turns out to be 9 hundredths. Okay, check out some more of your stuff from Hawks. This is going to be one in which you're going to be very happy you have your little chart, because you're going to use your chart. .625 to the 3/4. Now you can do this a couple of ways. And obviously one way is up here, this is the 4th root of 625, whatever that is, cubed. I look on my chart, find that the 4th root of 625 is in fact 5. I look on my chart, find that 5 cubed is 125. Here's another way you can do it. You can substitute something for 625. This is what I call a chart number. Hey, it shows up in your chart. And if you look at your chart, you're going to find that 625 is 5 to the 4th power. So in the place of 625, I'm going to substitute 5 to the 4th power. Substituting 5 to the 4th power. Wait a minute, I've got powers to a power. I have this example right here, this property of exponents. powers to a power. I multiply my two exponents. Make that a fraction just to make it a little easier. 4 over 1 times 3 over 4. My 4's cancel. 5 to the third. Oh my goodness. That's still 125. So a couple of ways you could do it. One is to use the radical translation of a fractional exponent. The other is to substitute. In the place of 625, I substitute what 625 is, 5 to the 4th. Same answer. That's reassuring. All right, let's try it. All right, Hawks is also going to ask you to change your radical expressions into fractional exponents. So it's going to ask you to go backwards with our translation of one to the other. So here's what I got. Cube root y to the 4th times the cube root of y to the 5th. That looks overwhelming, except I can change this and this to a fractional exponent, right? Y is obviously the base. And here's the way I get my fraction and without getting it mixed up. The index is always the denominator. So I got a fraction. The index is the denominator. The exponent is the numerator. So the cube root of y to the 4th is the same as y to the 4 thirds times, same thing, y is the base, obviously. The index is the denominator. That must be my numerator. Check it out again. This is an example of first property of exponents. Same base. What do I do with my exponents? I add them up. Same base in a multiplication problem. What do I do with my exponents? I add them up. 4 thirds plus 5 thirds. Hey, same denominator. No problem. Just add my numerators. That's y to the 4 plus 5. 9 thirds. That's y to the 3rd. So that's what I would submit in my Hawks answer blank. Y to the 3rd power. What did we do? We took radical expressions, changed them to fractional exponents. We used our properties of exponents to figure this out. Hey, I'm multiplying with the same base. That means add my exponents. Add them up nicely. Y to the 3rd. Yeah, what if they don't add up nicely? Let's look at an example of that. B to the 5/6 over b to the 2 thirds. Again, I just simply ask to simplify the expression. That looks like this guy right here. And it doesn't take me long with my calculator to figure out that 5/6 is larger than 2 thirds if I put them into decimal form. So there's my larger exponent. So I'm going to subtract the smaller exponent from the larger exponent. That's what the third property of exponents says. Same base in a fraction, you subtract the smaller from the larger wherever the larger one happens to be. Now, that's what I got to do. I got to figure out what 5/6 minus 2 thirds is. We don't have the same denominator, so I can't just subtract the numerators. I'm either going to have to go old school and get a common denominator, or I could use the handy dandy method. Remember it? It's the way to combine two fractions with different denominators. First step, multiply your denominators. 6 is 18. Secondly, start in the upper left. And cross multiply. So start here, cross multiply. 5 times 3 is 15. Do whatever the sign tells you. It tells me to subtract. 6 times 2 is 12. I get 3 over 18. That's not simplified. Both divisible by 3. I get 1/6. So 5/6 minus 2/3 is 1/6. So I get b to the 1/6 power. Hey, use your handy dandy method anytime you can. Combining two fractions, adding or subtracting fractions with different denominators. Just 2 steps. Multiply your denominator. Start in the upper left. And cross multiply. Doing whatever the sign in the middle tells you to do. Okay. Let's try another. A to the 3/5 times A to the 3/4. This again is a Hawk's problem. Now, hopefully experience and familiarity is going to allow you to look at this and go, hey, that's just like, which one? Same base, add my exponents. So I'm going to do a to the that plus that. Again, I'm being asked to combine two fractions with different denominators. I can either get a common denominator or I can use the handy dandy method. 3/5 plus 3/4. 2 steps, multiply my denominators. Start in the upper left and cross multiply. 3 times 4 is 12 plus 5 times 3 is 15. I get 27/20. Anything simplifying to that? I don't think so. So this is a to the 27/20. All right, let's do one with a negative fractional exponent. Oh my goodness. All right. Here's an example of one in which I'm going to, I don't think I had mentioned this to you before. Let me mention this to you now. When I have negative exponents, I can move them to the other part of the fraction and change the sign of my exponent. For instance, a to the -2 is the same as 1 over a to the 2. We did talk about that, didn't we? So I have something to a negative power. I can move it to the other part of the fraction and change the sign of my exponent. Because remember, Hawk's does not want you to end up with a negative exponent. You got a negative exponent, you're not finished. So this becomes negative 100 to the positive 1/2 power. 1 over that. Now I'm able to change a fractional exponent to a radical expression. Let's do that. The base, negative 100, goes in my radical. The denominator is my index. The numerator is my exponent. Now I don't need an exponent of 1, that's redundant, so I don't have to put that. And likewise, if you have a square root, I don't need to put the 2 there for the index, that's redundant also. So basically what I'm looking for is square root of negative 100. Now here's where if you refer to your calculator, it's going to go, I don't know. I got no answer for you because there is no real number for which I can take the square, that I can square and get negative 100. That's what it's asking here. Square root of negative 100, your calculator is going to tell you error. So what you're going to put in your Hawks submission is no real number solution. And you get a square root of a negative, no real number solution. Let's work one more. This is also one of your Hawks problems. X to 1/2, negative 1/2. Now you may recall me suggesting, it's just a suggestion, that anytime you have a power to a power, go ahead and multiply your exponents. That's what I got here, power to a power, I multiply my exponents. So it's going to give me 1/2 times negative 1/2. Gives me x to the negative 1/4. Okay, negative power, not finished. Move it to the other part of the fraction and change the sign of your exponent. And that's exactly what Hawks will take, 1 over x to the 1/4 power. All right, next week is our testing week. We will review, go over problems. I'll go over problems with you in a video format and hopefully well prepare you for the test. Again, you may use your notes on your test. So have your notes handy when the test is presented. I do not yet know, we're going to have a meeting tomorrow, I do not yet know when the test will be presented to you, how long you will have. I'll get all that information to you as soon as I know it. All right, stay well. I'll see you next time.